TC cable should not be used for underground service at a pier. Using TC cable for underground service at a pier violates several code requirements. The National Electrical Code, Article 336, outlines underground installations. TC cable is not listed in Table 336.102 as an approved type of cable for underground use. National Electrical Code Article 400 concerns flexible cords and cables. TC cable is not a flexible cord or cable and therefore is not intended for underground burial. There are several reasons why TC cable is not suitable for underground applications. Firstly, it lacks water resistance. TC cable is not designed to withstand moisture and can easily absorb water. This absorption can lead to electrical hazards and premature cable failure. Secondly, there is a vulnerability to corrosion. The conductor and insulation materials in TC cable are not corrosion resistant. They can degrade in harsh underground environments. Thirdly, the strength and durability are limited. TC cable is not as strong or durable as UF or use cable. This makes it more susceptible to damage from soil movement or other external forces. Approved cable types for underground pier service include UF cable, which stands for underground feeder. This cable is designed specifically for underground burial. It provides moisture resistance and mechanical strength. Use cable, which stands for underground service entrance, is also approved. This cable is similar to UF cable but with additional features for service entrance applications. Using TC cable for underground service at a pier can have serious consequences. These consequences can include electrical shocks and fires. Defective TC cable can allow water to seep into the conductors, creating electrical hazards. Damage to the cable can also occur. Underground conditions can damage the cable, leading to premature failure and potential outages. Finally, using TC cable can result in code violations. Failure to use approved cable types can result in code violations and potential legal issues. When installing electrical services underground, it is important to use cable types specifically designed and approved for that purpose. UF and use cables are engineered to withstand the harsh conditions present in underground environments, ensuring safety and longevity. TC cable, on the other hand, lacks the necessary protective features and is therefore not suitable for underground burial. The National Electrical Code provides detailed guidelines and requirements for electrical installations, including underground wiring. Adhering to these codes is essential for ensuring the safety of people and property. Using the correct type of cable is a critical aspect of complying with the NEC. When selecting cable for underground applications, it is important to consider factors such as moisture resistance, corrosion resistance, and mechanical strength. UF and use cables are specifically designed to meet these requirements, making them the appropriate choice for underground pier service. In addition to using the correct type of cable, it is also important to follow proper installation practices. This includes ensuring that the cable is buried at the correct depth and protected from physical damage. Proper grounding and bonding are also essential for safety. Electrical work should always be performed by qualified and licensed electricians who are familiar with the NEC and local codes. These professionals have the knowledge and experience to ensure that electrical installations are safe and code compliant. Attempting to perform electrical work without the proper training and experience can be dangerous and can lead to serious consequences. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before undertaking any electrical project. In summary, TC cable is not approved for underground service at a pier due to its lack of water resistance, vulnerability to corrosion, and limited strength and durability. UF and use cables are the approved types for this application. Using TC cable can result in electrical hazards, cable damage, and code violations. Always follow the NEC and consult with a qualified electrician to ensure safety and compliance. Underground electrical installations require careful planning and execution to ensure long-term reliability and safety. The selection of appropriate materials, including the correct type of cable, is a critical aspect of this process. By adhering to the NEC and utilizing approved cable types, you can minimize the risk of electrical hazards and ensure the safe operation of electrical systems. Remember to always prioritize safety and consult with qualified professionals when working with electricity. Their expertise can help you to avoid potential dangers and ensure that your electrical installations are up to code. Furthermore, consider the long-term maintenance of underground electrical systems. Regular inspections and testing can help to identify potential problems before they become serious hazards. Proper maintenance can also extend the lifespan of electrical equipment and prevent costly repairs. In addition to the technical aspects of underground electrical installations, it is also important to consider the environmental impact. Use environmentally friendly materials and practices whenever possible to minimize the impact on the surrounding environment. This includes properly disposing of waste materials and avoiding the use of hazardous chemicals. By taking a holistic approach to underground electrical installations, you can ensure that they are safe, reliable, and environmentally responsible. This approach will benefit both people and the environment for years to come. It is also worth noting that the NEC is regularly updated to reflect advancements in technology and changes in industry best practices. It is important to stay informed about the latest version of the NEC and to ensure that your electrical installations comply with the most current requirements. Continuing education and professional development are essential for electricians and other electrical professionals to stay up to date on the latest codes and standards. These resources can help them to provide safe and reliable electrical services to their clients. In conclusion, the use of TC cable for underground service at a pier is a code violation and should be avoided. UF and use cables are the approved types for this application due to their superior water resistance, corrosion resistance, and mechanical strength. Always follow the NEC, consult with a qualified electrician, and prioritize safety when working with electricity. By taking these precautions, you can ensure the safe and reliable operation of underground electrical systems. Underground electrical systems are a critical component of modern infrastructure, providing power to homes, businesses, and other facilities. Proper installation and maintenance of these systems are essential for ensuring the continued availability of electricity and preventing electrical hazards. By following the guidelines outlined in the NEC and working with qualified professionals, you can contribute to the safety and reliability of underground electrical infrastructure. The use of TC cable in underground applications is a common misconception, and it is important to understand the reasons why it is not permitted. TC cable is primarily designed for use in dry, indoor locations and lacks the necessary protection to withstand the harsh conditions present in underground environments. The outer jacket of TC cable is not waterproof and can easily allow moisture to penetrate the cable, leading to corrosion and electrical faults. Additionally, TC cable is not as mechanically robust as UF or use cable and is more susceptible to damage from soil movement, rocks, and other underground hazards. UF and use cables, on the other hand, are specifically designed for direct burial applications and are constructed with materials that are resistant to moisture, corrosion, and physical damage. These cables are also typically thicker and more durable than TC cable, providing added protection against underground hazards. When selecting cable for underground applications, it is important to consult with a qualified electrician or electrical engineer to ensure that you are using the correct type of cable for the specific application. Factors to consider include the depth of burial, the type of soil, the presence of groundwater, and the expected load on the cable. In addition to using the correct type of cable, it is also important to follow proper installation practices. This includes ensuring that the cable is buried at the correct depth, protected from physical damage, and properly grounded and bonded. Improper installation can compromise the safety and reliability of the underground electrical system, even if the correct type of cable is used. Regular inspections and maintenance are also essential for ensuring the long-term performance of underground electrical systems. Inspections can help to identify potential problems before they become serious hazards, and maintenance can help to extend the lifespan of the cable and other components. Some common maintenance tasks include checking for signs of corrosion, damage, or wear, and testing the insulation resistance of the cable. If any problems are detected, they should be addressed promptly by a qualified electrician. Underground electrical systems are a valuable asset, and it is important to protect them from damage and ensure their continued operation. By following the guidelines outlined in the NEC, using the correct type of cable, and implementing proper installation and maintenance practices, you can help to ensure the safety and reliability of underground electrical infrastructure. Furthermore, it is important to be aware of the potential hazards associated with digging near underground utilities. Before digging, always call the local one-call center to have underground utilities marked. This will help to prevent accidental damage to underground cables and other utilities, which can result in serious injuries or property damage. In summary, TC cable is not suitable for underground applications due to its lack of water resistance, corrosion resistance, and mechanical strength. UF and use cables are the approved types for direct burial applications. Always follow the NEC, consult with a qualified electrician, and prioritize safety when working with electricity. Proper installation and maintenance are essential for ensuring the long-term performance of underground electrical systems. And remember to call before you dig to prevent accidental damage to underground utilities. The selection of appropriate electrical materials for specific applications is a cornerstone of electrical safety. The National Electrical Code provides a comprehensive framework for ensuring that electrical installations are safe and reliable. Adherence to these codes is not merely a matter of compliance, but a fundamental responsibility for all involved in the design, installation, and maintenance of electrical systems. In the context of underground wiring, the choice between TC cable and UF or use cable is a clear-cut example of the importance of selecting the right material for the job. TC cable, designed primarily for indoor use, lacks the inherent protection required to withstand the rigors of an underground environment. Its vulnerability to moisture, corrosion, and physical damage makes it an unsuitable choice for direct burial applications. UF and use cables, on the other hand, are specifically engineered to thrive in underground conditions. Their robust construction and resistance to environmental factors ensure that they can provide safe and reliable electrical service for many years. The decision to use UF or use cable for underground wiring is not simply a matter of preference, but a matter of safety and code compliance. By adhering to the NEC and selecting the appropriate materials, electrical professionals can minimize the risk of electrical hazards and ensure the long-term integrity of electrical systems. It is also important to recognize that the NEC is not a static document. It is constantly evolving to reflect advancements in technology and changes in industry best practices. Staying up to date on the latest revisions of the NEC is essential for all electrical professionals. Continuing education and professional development are vital for ensuring that electrical installations are safe, code compliant, and technologically advanced. In addition to selecting the right materials and adhering to the NEC, proper installation practices are also crucial for the success of underground wiring projects. This includes ensuring that the cable is buried at the correct depth, protected from physical damage, and properly grounded and bonded. Improper installation can compromise the safety and reliability of the underground electrical system, even if the correct type of cable is used. Therefore, it is essential to employ qualified and experienced electricians who are familiar with the NEC and proper installation techniques. Regular inspections and maintenance are also essential for ensuring the long-term performance of underground electrical systems. Inspections can help to identify potential problems before they become serious hazards, and maintenance can help to extend the lifespan of the cable and other components. In conclusion, the use of TC cable for underground wiring is a code violation and should be avoided. UF and use cables are the approved types for direct burial applications due to their superior water resistance, corrosion resistance, and mechanical strength. Always follow the NEC, consult with a qualified electrician, and prioritize safety when working with electricity. Proper installation and maintenance are essential for ensuring the long-term performance of underground electrical systems. By adhering to these principles, we can ensure the safety and reliability of electrical systems and protect people and property from electrical hazards.